Okay, so the next example would be to use algebra to solve a trig equation. So one way you do this is to isolate everything to one hand side, then you can factor out and solve from there. So our question is, we have to solve 2 cosine x squared, that's equal to negative root 3 cosine x. We need to find solutions over negative 180 degrees to positive 180 degrees. So step 1, move everything to the left-hand side. And I know that's a good idea because there's both cosines in both terms. So add the root 3 cosine x to the left-hand side. Okay, and the reason why it's a good idea to do that is because once we see I have cosine x and cosine x, I can factor that out. Okay, which leaves me with 2 cosine x plus root 3. Now from each factor, I can isolate, solve, and then find all the solutions within the domain. Okay, from the first factor, cosine x, that's going to equal 0. Okay, I first would look at my cast rule. Now 0 is positive and negative, so that's all 4 quadrants. The reference angle for cosine 0, okay, just quickly calculate that. That's going to be 90 degrees. And I should have known that because the graph of cosine will cross at 90 degrees. Okay, that's quadrant 1 and quadrant 2. And then it will also cross at 0, okay, because that cosine x equals 0. In quadrants 3 and 4, if I use a reference angle of 90 degrees, we'll go down to 270, and 360 minus 90 is also 270. Okay, so for cosine x equals 0, I have solutions 90 degrees and 270 degrees. But does that fit within the domain? The solution needs to be between 180 and negative 180. 270 doesn't fit that, but 90 degrees does. But because we're going into the negative degrees, what I can do is find my coterminal angles. So 90 minus 360 degrees, that equals negative 270. Okay, and then 270 degrees, okay, starting from here, subtract 360 degrees, that equals negative 90 degrees. So just from cosine x equals 0, between the domain of negative 180 to 80, my solutions are negative 270 degrees, negative 90 degrees, 90 degrees, and 270 degrees. Okay, but take a look again, which ones fit in the domain, which ones don't. Negative 270 and positive 270 do not fit within the domain. So my only solutions are positive and negative 90 from cosine x equals 0. Okay, next factor, we have 2 cosine x plus root 3 equals 0. So that means cosine x will equal negative root 3 over 2. Cosine, if we use the cast rule, is negative in quadrants 2 and 3. And our reference angle is 30 degrees. Okay, so 30 degrees in quadrant 2 would be 150 degrees. And if we apply 30 degrees in quadrant 3, okay, that gives us 210 degrees. Now 210 degrees is over our domain, so we know that won't be a solution. But we need to find some coterminal angles to get into the negative degrees. So 210 minus 360, that gives me negative 150 degrees. Okay, that fits in the domain. And we can test it 150 minus 360 degrees. That gives me negative 210, which is outside of the domain. So I don't even need to include that. Okay, so I have negative 150, positive 150, negative 90, positive 90 as my solutions. And just to show that answer clearly above, x equals positive and negative 90 degrees and positive negative 150 degrees. Okay, that's how I would solve these algebraically. Just keep in mind, again, we could put this in our calculator and solve for the x-intercepts like we did in the example before. Okay, always make sure you're paying attention to the domain because you have solutions that may or may not fit in that domain. Okay, so always be aware of that. Alright, another important skill is to figure out what the non-permissible values would be for trig identities and equations. Okay, but specifically in this identity, we have some non-permissible values. Okay, from this denominator, we know we can't divide by 0, therefore 1 plus sine theta cannot equal 0. Isolate the sign, and sine theta cannot equal -1. Okay, now the reference angle, we just take a look at the casserole here. Okay, sine is negative in these two quadrants. The reference angle is 90 degrees, where sine theta equals 1. Okay, and if we apply that, it's going to be at 270 degrees. Okay, that's where our minimum is reached on the graph. So theta in this case cannot equal 270 degrees. Now, thinking about the graph of sine, that keeps going, and going, and going. So, sine exists at -1 at 270, okay, plus another 360, plus another 360. So the general non-permissible values will be 270 degrees plus 360 degrees times n, where n is an integer. Okay, so theta cannot equal 270 degrees plus 360 degrees n. Now the other non-permissible value comes from the right-hand side. We know that cotangent theta cannot equal 0 because we're not allowed to divide by 0. Okay, but cotangent is actually 1 over tan theta. Okay, that can equal 0. But we have tan theta in the denominator, so essentially tan theta cannot equal 0. So looking at the graph of tan, okay, we have solutions at 0, 180, and what's the period of tan? It's 180 degrees. So every 180 degrees, we're going to have tan theta equals 0. So that means the restriction is that theta cannot equal 180 degrees times n, where n is an integer. Okay, so we have two restrictions. This is the restriction for the left-hand side. This is the restriction for the right-hand side. Then we get to proving identities. Okay, so on to the next question, number 9. This isn't the question I wanted to do with you guys, so if you could just cross it out. Okay, and instead, we are going to do 1 minus cosine x over sine x equals tan x minus sine x over tan x sine x. So hopefully you have your formula sheet nearby because you will need to use some identities to prove this identity. Okay, this one's pretty straightforward though. We just need to replace tan x with the quotient identity sine x over cosine x. That's the only thing we're going to replace for now. Okay, so left-hand side, pretty straightforward, not much we can do, but the right-hand side, that looks more complex, so we want to start there. I'm just going to write the left-hand side out first. So we have 1 minus cosine x over sine x, and now I'm going to deal with my right-hand side. Okay, my right-hand side being tan x minus sine x over tan x sine x. So instead of tan x, let's write it as sine x over cosine x. So sine x over cosine x minus sine x, that's my numerator. And then I'm going to replace this tan with sine x over cosine x and multiply it with sine x. Next up, we need to get a common denominator in this numerator. So I have sine x minus sine x cosine x all over cosine x. Okay, I just multiplied this term by cosine x over cosine x. Okay, all over, in the denominator, sine x times sine x is sine x squared over cosine x. If you have the same thing in the denominator of the numerator and denominator, they can just cancel out. Moving up, I have sine x minus sine x cosine x all over sine x squared. Can factor sine out of the terms in the numerator. And I'm left with 1 minus cosine x over sine x squared. One of these signs can cancel out. So I'm just left with 1 minus cosine x over sine x. Does that look like the left-hand side? Yes, it does. Voila. Okay, then sometimes we're asked to use our trig identities to solve equations. Okay, typically you want to sub in an identity whereby you can factor after. So if I have a term with cosine and a term with sine x squared equals something, okay, what I can do is look, is there an identity to replace the sine x squared? And there's the Pythagorean identity. Okay, so cosine x squared plus sine x squared equals 1. So I'm going to replace this sine x squared with 1 minus cosine x squared. Okay, let's see what that looks like. So I have cosine x minus 2, and instead of sine x squared, I'm going to replace that with 1 minus cosine x squared. That will equal 1. Okay, expand that 2, I get cosine x minus 2 plus 2 cosine x squared equals 1. Move everything to the left-hand side, I get 2 cosine x squared plus cosine x. Negative 2 minus another one is minus 3. We need to factor now. So maybe let's let cosine equal a. Two numbers that multiply to negative 6 and add to 1. Okay, so I'm going to get 2a. Looks like it will be 3 and negative 2. 2a squared minus 2a plus 3a minus 3. Okay, factor by grouping. Can take out a 2a from the first group and I'm left with a minus 1. Take out a 3 from the second group, left with a minus 1. But so then I have a minus 1 multiplied by 2a plus 3. And from here, a equals 1 and a equals negative 3 over 2. But what we have to remember is that a is not a is cosine x. So from our first factor, a is 1, that's actually cosine x equals 1. Okay, and from our second factor, a is equal to negative 3 over 2, that's actually cosine x is equal to negative 3 over 2. So from cosine x equals 1, use our cast rule, we have solutions in quadrants 1 and 4. The reference angle is going to be 0. So that means I have 0 degrees and 360 degrees. Okay, 0 in quadrant 1, 360 in quadrant 4. Looking at the domain, it's going between 2 pi and negative 2 pi. So if I were to stretch this out, okay, 0 plus 2 pi is 2 pi. 0 minus 2 pi is negative 2 pi. So I have solutions negative 2 pi, 0, and 360 is actually 2 pi. Okay, so that's from the first ratio. Let's look at the second one. Cosine x equals negative 3 over 2. Well, remind you of the graph of cosine. What is that minimum at? Negative 1. Would it ever touch negative 1.5 right here? No, the graph doesn't exist. And if you try to find a reference angle for this, you won't get one. So our only solutions are x equals negative 2 pi, 0, and 2 pi. Okay, and last question, we're going to use the sum and difference identity to determine the exact value of cosine 165. So I'll just remind you of the sum identity for cosine. So cosine A plus B is equal to cosine A cosine B minus sine A sine B. We need to figure out what is our A plus B to equal 165. So cosine 165, that's actually equal to cosine 135 plus, you always want to choose a special triangle, 30 degrees. Okay, and the reason why I knew 135 as well was a special triangle, because when I apply the 135 degrees, I'm left with a 45 degree special triangle. Okay, very important. You need to use special triangles, angles, or special angles when you're expanding the sum or difference identities. So now I know A is 135, B is 30 degrees, so I'm just replacing A with 135 and B with 30. So I have cosine 135, cosine 30, minus sine 135 and sine 30. Okay, so cosine 135, if I'm using special triangle, like I said, 45 degrees, we know that has a unit or radius of 1, root 2 over 2 on the x, and root 2 over 2 on the y. Because we're in quadrant 2, though, it's going to be a negative root 2 over 2 on the x-axis. Okay, so cosine 135 is the x-coordinate, negative root 2 over 2, getting the exact value. Okay, dealing with 30 degrees, okay, in quadrant 1, okay, that's root 3 over 2, 1 over 2, and 1. So cosine 30 is root 3 over 2. Sine 135 is the y-coordinate, root 2 over 2. And sine 30, again, the y-coordinate, 1/2. We just have to plug these, or put these all together. So root 2 times root 3, negative root 6. 2 times 2 is 4. Okay, root 2 times 1, root 2. 2 times 2 is 4, and we're subtracting. So simplify that, and we get negative root 6 minus root 2 all over 4. That is the exact value of cosine 165.